All right, so time again. Time for a coding session. Last couple of sessions we got our SIMD into a pretty good place, I think. We could do with some better testing, like I mentioned at the end of the video. Actually, I think there's an area here. Was it here? Put a note here about that. Also, we only do plus equals. It would be nice if we did if you could just do plus, array3 equals array1 plus array2. That would be nice. But let's move on to something else now. I would like to kind of re-architect a little bit the compiler. The main change I want to make is that I want the AST for each procedure to be separate. So we keep a procedure object which has its own AST, and we can type check them separately and generate them separately. And the benefit of that is that we can then be type checking one procedure, and when we get to a call, we can at that point decide what variation of a procedure to generate. For example, there's a couple of features that I want to add that will be helped by that. There's generics, where the type of a parameter will get decided by the call. So whatever parameters you put in, the types of those parameters will determine the variant of the procedure that actually gets generated. So it'll help us support that. And the other one is when we go to the GPU, we will want to compile a procedure for a different target. If we see that a procedure is being used as a GPU kernel, then we compile it to the GPU. That same procedure might also get used somewhere else by the CPU, in which case we would also compile that variant. So that's the kind of thing I want to enable. Also, having the procedures separate like that does open the door to processing them in parallel, which would also be very nice. We could be a lot faster. So I think maybe the place to start is this modules file. We're kind of going to take this module concept and really extend it. In fact, I might actually rename this to program, because I am going to create a program struct as well. Program, module, and procedure. These are all the things that I want to have, and let's not put these context things in here. Instead, the program is going to have a map of modules, so named modules essentially, and also procedures. So those are named procedures. Within each module, I'm just trying to think off the top of my head what we need. One thing we will need is imports, so we know which modules are imported by this module. And everywhere except for the program, I'm going to refer to other parts of the program by name. So here, this module is referring to another module by name. Because if we take a pointer to something within a map, and then later we modify that map, it can invalidate the pointer, so it gets really messy. So we'll just refer to them by name. So there's also here, we're going to have references, which is references to other procedures. Could be called calls, I guess, but I think that just needs to be a list of things. I don't think that really needs to be a map. This needs to be a map because within this module, we may refer to the other module using a different name. you can sort of create an alias for the module. So we need this mapping. And here I'm going to call this statements. And we do need, because we did have this type checking context in there, we do actually need some identifiers since we took the context out. I think we only need to save the identifiers at the module level. So let's put them there. And now we don't have this static imported modules because the program contains the modules. And this is our new program structure, which is very nice. I've just realized that this is imported but not used. And I've just realized that actually that's wrong and it is used right here. Okay. So we want to import a module. We need to give a program that we're going to import that to. So we'll look in the modules of the program to see if it already exists. And if it does, do nothing. And down here, after we've tokenized and parsed, so now that we have an AST tree, like what's another example? I can't remember. But you know, an acronym where you say AST tree, even though the T stands for tree. Anyway, we'll add the module. So this module, it's just going to be an empty module, I think, with the name that we wanted to load it with. Yeah, we don't need to put anything else in it right now. And we'll create a procedure with the same name. With the same name? Yeah, I think with the same name. And the statements are the nodes. So that's instead of doing this. We don't need to do this. And I think what we're actually going to do is pass in a context. So we're going to build a type checking context and pass that in. So this type checking context, we're going to change this also. So we do want to have identifiers in here. We need to maintain that as we go in and out of nested scopes and things. We need to maintain the list of identifiers that are available for that scope. But I basically want to maintain also information about where we are in the program. So again, we're going to just refer to the module by name and the procedure by name, so we don't get any pointer madness. So we know where we are in the program and what identifiers we have available. That's basically what the context is for. So as the program module name is name and procedure name is name. Cool, I think that's basically it. That's how we import a module. Right now we're just going to type check the module immediately. So here we're actually passing in a context. And anywhere we have this, I guess we'll replace with context.identifiers. But let's just replace them in this procedure. So for now, in selection, replace all. Like so. Another thing I was really wanting to do was these kind of conditions. So this nested if is basically saying, is this an import statement? And for clarity, I'm just going to extract that. We're also going to use it in multiple places. Import statement. So yeah, it's nice to have it just as a procedure. So then when we call the procedure, it's very clear what it is we're checking. Return identifiers, return false. Cool. So now, what's going on here? What's wrong with this? Has no field identifiers. Oh, sorry. Wrong context. So now, actually, I'm going to flip this and say if it's not an import statement, then, no, not return, but just let's skip it. We only want to process import statements here. Then we don't have to nest so much. Beautiful. I think we also need to change some of this stuff because we changed our input module. We need to pass the program in, and this is the, no, this is the context.program context.module name dot imports that we are appending to. We're appending this. Oh no, the imports is a map, right? So actually we're saying imports, this equals name, reference equals name. So I guess actually we need to get the procedure. Which is the context.program .procedures, procedure name. And that's the main procedure.statements. Like so. So hopefully that should be it tends not to like when you kind of index and when you access into a map and then also do more stuff. Cannot index of type program. No, that's still an old error. Takes a while for the old IDE to catch up. So here's another one. This one is saying is basically saying, is it a return a type alias statement? Does it have a reason to be unhappy? I don't think so. I'm just going to ignore that for now. Come on, Light. You can do it. And again, I'm going to invert this and do a continue. We want to resolve types for every statement, but only for type aliases we want to go in here and do this stuff. So I guess this is just the context. Yeah, it's not happy with this. So let's say module to imports. Hopefully that's happy. Yeah, it looks happy. So here we can take this away. That looks a bit nicer. And this one is saying whether it's a procedure statement. I'll call it. Like so. So where is this? If it's not a procedure statement, actually we can probably say, might be clearer to call these statements. And that needs to be a pointer. Cool, so is procedure statement. I think we need to hold on to these though, because they're used. Yeah. There we go. And here this is saying if it is a type alias statement, we don't want to process it. We don't want to type check those. And this is just the context. Okay, cool. So I don't think we've actually changed anything that happens here yet. But this is when we go through the procedures. No, sorry, this is the type aliases. When we go through the procedures, we want to create procedure objects to add to our program, right? That's like kind of the whole point of this stuff. So we'll create a procedure. And this is a little bit weird, but I'm going to add this statement as the one statement of the procedure. So this statement is actually the assignment that declares the statement. So, for example, with this procedure here, we are saving this whole statement. We're saying this is the statement of in the procedure. See, we're appending it to the statements of the procedure, this whole thing, when really this scope should be the statements, either this or the whole scope is what the procedure statements should be. But just for simplicity right now, because it'll work with other code we already have, I'm going to make this whole thing statement of the procedure. So now that we have a procedure, we can go to our procedures. Sorry, I've done this wrong. Let's not copy from somewhere else. Program.procedures. We need the name, which is this. And that's the procedure. Okay, and now we type check all of these. I think because we are now taking these statements, these procedure statements, and making them their own procedure AST, which will get type checked separately. I also want to say that for the main procedure, we should ignore those because they will get type checked as part of other procedures. Okay, so far so good. I also want the module I kind of don't like, because we're modifying the procedures, right? Modifying the procedures here, and then afterwards we use, yeah, this is the dangerous thing. So maybe we should do that here, and maybe for these other ones we can just do this. Let's see. And just to be clear, we use the module name because then it's quite clear that we're getting the procedure of the module. That's the main procedure of the module. And when I say main procedure, what I mean is, like, this file is a module, right? The main procedure is all this code that's happening in the body of the procedure, just code that's directly here. It's not within any named procedure, it's just the body of the program. And then this is a named separate procedure here, but everything outside of it, this for loop and everything, is what I consider the main. It'll become part of main, right, when it's compiled. Right, so the reason that I wanted that there is because afterwards this main procedure, and when we're type checking, I'm just thinking that when we type check, no, that's not going to go into nested procedures, so that's okay. I'm just very worried about these pointers that I'm grabbing. But here, oh no, it's not the main procedure, it is the module that I want. The module identifiers equals the context identifiers. I think if we do that, it's not going to work because of that whole chaining business. Maybe it's happy. No, it's not. Okay. So once we've finished type checking the main procedure, the identifiers and the context should be all those that are available as part of that module. Cool. Hopefully this will be happy soon. Yep. Now directly after that, what I want to do is go through and type check all the procedures. These procedures we just added. So we probably need to keep a list of them. So we'll just do a simple dynamic array. I do way too many of those. I'm sure that if we go through at some point and change them to like a better data structure, or something that allocates memory a bit nicer, probably get some performance gains. But we're just going for simple right now. So now we have this list of parameter names, procedure names. So for procedure name and procedure names, we're going to do something similar to this. We're going to grab the procedure with that procedure name. We're going to go through its statements. I don't really have support for these things in procedures yet. We're going to get to that, I think. We're going to get to a point where like you could have imports or type aliases or nested procedures, all that kind of stuff. But right now you can't do it. Or at least I don't support it, so I'm not going to put code there for it. Now the thing with these procedures is that if I just use this context, it's going to get polluted with a whole bunch of stuff from previous procedures. So I'm going to make a separate context, which is a copy of the type checking context. And we'll change the procedure name. And then we'll use that when we're type checking. So actually we need to do that before the loop. Before this loop, but every iteration of the procedure loop. Yeah, we do it. I think that better to take a pointer, and I want to make this inline explicit. Okay, while we're here, let's have a look at this. Yeah, we don't have references anymore, but we do have all that stuff, which I'd like to copy. So program equals context.program. Module name is module name. And then if we're inline, let's copy across the procedure name. Yeah, cool. So that should be happy now. Oh no, because it needs the Boolean, so we're not inline. Inline is basically meaning that the new context we're creating should see the variables in the parent context, but that's not true for procedures. Should see the identifiers in the parent context, I guess I should say. So that should type check all the procedures now. Everything should be type checked. We have some errors here, probably from refactoring business. Yeah, things like that. Okay, so here we're checking the return type, basically. So now it would be like context.program, context.procedure name. And then we look at the statements. Oh, context.program procedures. Then we look at there's only one statement. And the first child of that is the left-hand side. That's the left-hand side. So that's the procedure node. Yeah, I think this is a bit messy, and also it's only going to work it's not going to work like, because my program is supposed to allow you to just go like this, and then it will exit with code 5. This is not going to work for that, but I'm not actually using that feature right now, so it should be okay to just fix that up later. That needs a pointer now. So this here, this type check assignment where we come in here and do like procedure specific stuff, this is actually only going to happen here. No, not here. Here, when we're type checking these procedures, and they will just have one statement, which is the procedure statement. And look, we've just created a context. That is correct. So we don't need to do this, I don't think. I think we can just use the context that we're given, and it should be fine. I don't know if it's referenced anywhere else, but I'm sure we'll get an error if it is. Okay, so this is where we're looking for imported modules. So this is the name of the module, or it's like the alias, right? Because if we look at this import statement, this could be like FFF, and then we can refer to it like this. So this is like the alias that we have for this module. So we're just checking the imports. So it's like program.modules, context.module name. So the current module not very good at typing module, am I? Maybe we'll go like that, because I guess we'll need it again here. So if it's in the imports, then we want to get module.imports where this is the key. So this here is going to map to the proper module name. So we get that from the program modules. So this is like the imported module. And we get to look at the identifiers within the imported module. And if we find it, then we grab it. Yeah, I think that looks good. And down here, I think I decided this should not be an issue, because if we type check in our main procedure, where is it? When we're type checking our main procedure, we go through all the statements. We're not skipping the import, so it should get type checked, and the module identifier should end up in here. So we shouldn't need this extra check, I think. Fingers crossed. I think it's not needed. This is also looking for imports. So if we go context.program.modules, context dot module name, so that gets our current module, and we look at the imports. This is when we're trying to get the imported module. So again, that is like the module to imports mapped to the correct module name. And now we're looking at the imported module identifiers. Hopefully that resolves. Okay, cool. There's no generation errors. Yeah, there are generation errors. Okay. Yeah, because we're going to need to change the way that we move throughout, we decide which procedures. That's the main thing we want to do here, right? I can't even remember if I mentioned it. I was telling you all the benefits of things that we can do with this new approach. Actually, the one benefit that I want to realize today is that we can generate only the procedures that we are using. So we're going to keep track of the procedures that we reference from other procedures. That's what this list here is. And only generate those. So what does that look like? Well, I think instead of passing this in, we're going to pass in some references, basically. So I guess that would be like procedure names, pass it by pointer. I'm really not sure if that's necessary in Odin, but I get a bit confused about how that all works. And so for each procedure name that is referenced, we will first, I think we need to get the procedure. Let's do that, hey? Procedures, procedure name. So and that's the references we're going to put in there. So then here we'll put the initial references from main, and then we will find, for all of those procedures, we will generate the procedure. Which is just generating the first statement, basically. This is where having it structured the way we do makes things a bit easier. I think it needs to be a pointer. And then we generate all the procedures that it's referenced. We will also need to keep track of which ones we've already generated so we don't do duplicates. But I think we can basically cut that out. And we need to update our context so it has something similar to our other context. You know, the stuff that tells us where we are in the program, which means we don't need that. I'm not sure if we actually need to keep track of the module name for now, so let's leave that out. Yeah, I'm just thinking when we generate, we should probably pass in a context like we did for the type checking. That's kind of consistent, isn't it? Did we just call this one context? Yeah, I guess we did. So we need to create a program. We need to pass that into importing our main module, which will then recursively import other modules. Now we need to make this gen context, which will be program equals pointer to program, and is it procedure name? procedure name is name, I guess, you know, the name of the main module. Okay, that looks good. So we don't need this. We haven't got to that yet. We're working on these. So yeah, this could be like context.program.procedures, context.procedure name dot references. I think it needs to be a pointer to it. So there's the initial references. We should actually loop through all of our modules that we have imported and contribute any statements they have to the overall main. But right now, our standard lib doesn't have anything to contribute. Well, I guess it has this, doesn't it? But that's nothing to contribute to generation, actually. So let's leave it like this. I think we haven't, oh no, we have fixed that up. This looks happy. But like I said, cannot take a pointer. Yeah, probably we need to go like main procedure like this. Probably now it'll be happy. Don't need a pointer to these things. Is it going to be happy now? Don't know. Yeah, it is. So the other thing I want to pass in here is generated procedure names. So this is a list of things we've already generated. Pass that in by pointer. Like so, so we'll add that on the end. Now, before we do anything, we need to do a linear search. Slice dot linear search, generate procedure names, procedure name, and if found generate procedure, skip. Nothing to do. We've already generated it. Cool. Otherwise, I guess we already have that as a pointer, don't we? Which is probably why this is... well, we need to change it to a slice. For that, so they should already reference and be happy, I think. Okay, where are we at? So these generated procedure names also need to get passed when we recurse. Yeah, I think that should be all good. And this reminds me that each time, so the context, do we need to do like a context copy? Maybe we do. I don't know how important it is actually, but we can. But let's just make sure we copy everything properly. Thought I'd gone far enough. I guess that's only if it's in line. Okay. And there's also a close, but we don't need to copy these things for the close. So then when we're generating procedures, well, we generate a single procedure. we already do it. We do a copy here. Okay. Let's make this explicit too. When we close it, it is explicit when we close, but not when we open. Okay. I feel like there's an error in here somewhere. But no, maybe it's this. And we kind of need to do this here, I remember, because we need to close it before we return. So it's not inline. So I guess outside, when we're here, we don't really need to do a copy here, I don't think. I think we can just sort of go like, it's a bit hacky, but we can just update the procedure name. That should be enough, I think. What's wrong with that? Nothing. Okay, good. But there is like a bunch of red. What is all this red about? Oh, it's here. Generate statements. So what is this bit down here that's a problem? In proc. So I think, oh no, we can just say if it's not in, program.modules. That means that we're not in a main procedure. That's what this is trying to say. Then we do a regular kind of return. Otherwise, we do an exit syscall. That's the thing that I told you is probably broken right now anyway. Okay, I think that's right. So now we need to figure out how we're going to generate the statements. And I think for this, it's as simple as looping through the modules and generating the statements for that module, or for the main procedure of that module. So we can just do like program.procedures, get the procedure for that module name. Then when we generate statements, oh, so this is like recursing. So I think actually what we need to do is just like instead do this. We don't need to recurse. Get the statements, loop through them. So this is kind of our code from before where we check if it's a procedure, but we do have static here, which I don't think we have here. No, we don't. Oh, that's the import. So we're just saying it's not a member and it's a procedure. Whereas here we're saying it's not a type. Okay. The left-hand side is not a type. Okay, I'm not sure what that's about. But I do think we need to, when we go through the statements, we need to ignore type aliases. And procedure statements. I think we kind of also need to have this. It needs to specifically be a static one. So that's like get type of that is static. I think we specifically need this because if we don't have that in there, because we do have like statement assignments that we do want. Well, let's just make sure it's not a member. Let's try without that for now. We might need to add that back in. Okay. So now we're generating all the main statements that are not type aliases, not procedures. I guess actually, whoops. Oh my God, where have I gone? Import statements. There's no point there's nothing to generate for those. So we basically just loop through the modules and generate their statements. And because of the recursive nature and the most nested module in the import chain is the one that will get added to this list first, actually. Isn't it? Like if we go to program, when we're importing the main module, we will add the module and then type check. So actually the first module will be this one. And after that, it kind of goes. See, then we add after doing an import, which means that the most nested import will be the first one apart from this one. So that's a bit, but we don't have to worry about that right now. We'll probably get issues later on that we'll need to fix it. But right now this ordering is probably good enough. So we don't need to pass this module guy in. And that's probably why we have an error up here. So I think that's all good. The thing that we're missing though is in our procedures, we're assuming that there are references, but we've never actually added any references. So I want to do that during type checking. Yeah, so this is where we refer to an identifier in a separate module. So I'm going to get the type node like this. And then if the type node is a procedure, then we're going to add it to our references. So context of so it's this current module. Right, this current module. Oh no, it's the current procedure, which we don't have. So we get this procedure, which is the procedure of the same name. No, not necessarily. We get this procedure dot references. We want to append to that the thing that we're referencing, which is this. That name, isn't that right? Yeah, the child node value is the import name. The current node value will be the identifier that we're referencing. So the reason I'm doing it here, this is in type checking when we come across an identifier. So anytime we see an identifier that's referring to a procedure, I'm going to say we need to include that procedure. The reason I'm not doing it when there's a call of the procedure is because if we have something like, where is it, like the thread pull worker. See, this is a procedure. It's never called directly, but it is referenced here. And then in start thread, wherever that is, it will get called. See, it's passed as this func, which is then put on the stack and then called here. So, but that is not the name of thread pull worker. So we do it here. We need to do something very similar for if we're just looking at a local identifier. So this is where we're just looking at our context identifiers. So now we say the current procedure is referencing that value. Our procedures are still not namespaced, which is, I think, not great, and we really need to do something about that. Let's see. I don't think we have we might have time to get to that today, because I think it is actually a quick fix, or quick-ish fix. But yeah, this should mean that we have references now. So what happens when I try to run this? That's the big question, isn't it? Okay, so we got all the way to generation. We tried to generate a procedure. That procedure is import. We probably shouldn't generate an import because that's not a real procedure. I think just a little hacky way we can get around that is to add import to our list of generated procedures before we even start. Then it should just always skip it. Syscall. This one I'd thought about. At the moment we have syscall in here as a hard-coded thing, but what I realized is it's just an extern procedure, and we could actually, at the top of our standard lib, we could actually just declare it as an extern procedure. Extern, and then we don't need it hard-coded here. And because it's all declared and everything, it should then this should work. I don't know how that will actually make it work better, but let's see. I have a feeling it should work. So this is the syscall num. This is param 0, and we go all the way up to 1, 2, 3, 4, 5. I'm not actually sure why, but somewhere in my head it felt like that would fix this problem. Ooh. Did we just get an infinite loop? Oh. Oh wow, why did that take so long? Standard lib is not defined. In file proc param scope. Standard lib is not defined. Line 6. I guess it's here. Are we passing that down? Because we did, remember I was like a bit cheeky and I said, we don't need this. This is where it's looking for module names. Maybe when we are copying yeah, this is it. When we're copying identifiers down, if we find a module, we should copy that down. Modules, procedures, types, they should all be copied down. It does. Oh, I was going to say it worries me why it's taking so long, but it's because we're going through the whole test suite, isn't it? So it's actually good that it's taking a long time. It means that I guess it's going through all the tests and passing because we're not seeing any output otherwise. Oh dear. Let's try without tests and let's do a debug. I have a feeling it'll be okay. Procedure name func. Maybe this is where, do you remember I said we should skip things that are not static? Well, func. It's getting added to the list of references. Func. This is stack param, stack i64. This is in here. This is here because we're referencing something with a procedure type. It's saying, hey, here's a reference. But this here, I think we'll find that func is not, we don't have the context right now, but this is not static. So probably at type checking time when we're building these references, we should only, where is it? Yeah, we should only do it if we're looking at something static. So if the allocator is static. Because if it's not static, that means that it's stack based. Those are the only two options right now. And this is a stack variable. You know, this is a variable. This is not. This one here is not a stack variable. This is a procedure definition. But this is just a stack variable. So it would not have a static allocator, and we should not add it to our references. Where are we at now? Compare exchange. This is another one of these hard-coded ones. But I can't just declare this is an extern thing because we do have like a hard-coded definition here. And if we declare it as like extern in here, like this one, then it'll also declare it as an extern name, and then we'll get duplicate declaration. So we'll probably just have to do the hacky thing we did before with import. I don't really like it. So let's just put a message here so we know maybe to do something better later. Okay, all right. Awesome. So let's just make sure. I think we got past all the tests before and it was just that last thing that was failing. But let's just double check. And if we look at an individual test now, see it's only 190. I forgot to show at the start. But previously they had all the procedures in them, right? Now we have exit, print line, write, print, and assert. And those are all this stuff here is hard-coded, so it's always there. And then this is the main body of the test. So an assert refers to all of these other ones. Cool, everything's great. It refers to print, which then in turn refers to write. I think it also refers to print line. And it refers to exit because it performs an exit. Yeah, print line, exit. So it only has the procedures it needs. Wicked. We're just about in an hour. I'm kind of tempted to do this namespacing. Let's just do whip commit and try some namespacing. Okay, so I am very happy that I did that whip commit because after I did that commit, I actually continued and I spent like half an hour trying to get this this namespace procedures thing working and couldn't get it working. But I don't want to throw away this hour that I did because I think it's good. So I'm just throwing away the namespace procedures thing. I've already rolled back to this whip commit. So we're golden. I'm happy. Enough for today. Yeah, so thanks for stopping by. Have a good one. Ciao for now.